Today we're going to be graphing the sine and cosine functions, and we're going to look at all 6 trig functions, and then we're going to focus specifically on sine and cosine. So the first thing we're going to do is fill in the degrees and radians going from negative 360 to positive 360, and we're going to go by 45s. And you may want to look at the PDF version of the notes to fill these out. Now we're going to do the same thing with the radian equivalents. Now we're going to do the sine values. So sine of 0 is 0. Sine of pi over 4 is root 2 over 2. So that's approximately equivalent to 0.7. Sine of pi over 2, so we're looking at the y values, is going to be 1 at 3 pi over 4, 0.7. At pi, it's back at 0. At 5 pi over 4, we're at negative root 2 over 2, or negative root 7, or negative 0.7, negative 1, negative 0.7, and 0. To fill in these negative ones, we're just going to go around the unit circle going clockwise. So we'd go down, which is going to be negative 0.7, negative 1, negative 0.7, 0, positive 0.7, 1, positive 0.7, 0. All right, so I'm going to go ahead and graph sine. We're going to use these values in the table to do so. So these tick marks I'm going to label on my axes. This is going to be 1. This is going to be negative 1. And I'm just going to label the major ones. So this is going to be pi over 2, pi, 3 pi over 2, 2 pi. We're going to do negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So sine of 0, I'm going to start at 0, is 0. At pi over 4, we're at 0.7, so a little bit more than half here. Pi over 2, we're at 1. Then it starts going back down. So 0.7 to 0. We're at negative 0.7, negative 1, negative 0.7, and 0. Then we'll backtrack here. And you can maybe kind of already see the pattern here. And then we're up at positive 0.7, positive 1, 0.7, and 0. So when we connect these dots, we get this graph. Now it would keep going like this on forever. It's called a cyclic graph. It's going to keep repeating over and over again. So now we're going to fill in the cosine values. Cosine of 0 is 1. We're looking at the x values on the unit circles. Pi over 4 is 0.7. Pi over 2 is 0. Negative 0.7, negative 1, negative 0.7, 0. At 7 pi over 4, our x value is going to be a positive root 2 over 2, and at 2 pi, we're back at 1. Okay, going backwards. Okay, so now we're going to transfer this information to this graph. I'm going to go ahead and label this one in degrees, but typically we're going to just use radians to do all of this. So this is going to be 1 and negative 1. This is 90, 180, 270, 360, negative 90, negative 180, negative 270, negative 360. And we will graph. So the cosine graph, cosine of 0 is 1. So it's going to start up here at 1. Then it's going to go to that 0.7, then 0, negative 0.7, negative 1. And again, you're going to see the same pattern that we saw for sine. Backtrack. 0.7, 0, negative 0.7, negative 1, negative 0.7, 0, 0.7, and 1. All right, so we get this nice cosine curve. So these two graphs are going to be our main focus, but I want to go ahead and graph the other 4 just so you see what those look like. I'm going to fill in the values and then graph. So first I'm going to fill in the values for cosecant. These are all going to be the reciprocals of sine values. So I'm going to start at 0 again. So this is the reciprocal. So 1 over 0 is going to be undefined. So cosecant is undefined at 0. 1 over 0.7 is going to be 1.4. 1 over 1 is 1. 1 over this, and so on. All right, so there are those values. So anywhere sine is 0, it's undefined. Anywhere where it's 1 or negative 1, it's just 1 or negative 1. And so on. So now we're going to graph the cosecant. So this is going to be pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. The first thing I'm going to graph are the asymptotes. Anywhere where our graph is undefined on the cosecant graph is going to be a vertical asymptote. Hi, sorry. Oh, you're good. Thanks. So we have vertical asymptotes at 0, at pi, at 2 pi, at negative pi, and negative 2 pi. For my y values, I'm going to make this 1 and make this 2. This will be negative 1. This will be negative 2. All right, so our graph of cosecant. At 45 degrees, or pi over 4, our graph is at 1.4. Pi over 2 is at 1, and 1.4. So it actually looks like, almost like a parabola, but it is asymptotic, so it's going to just approach those values. At 5 pi over 4, we're at negative 1.4, at negative 1 and negative 1.4, and it's just going to keep repeating that. And then here, and then we're at 1, 1.4, 1.4, like so. So this is the graph of cosecant. Okay, so I also want to show you the graphs on the calculator, just to show you the relationship between sine and 1 over sine. So if I were to graph those, we have the sine curve that we graphed first, and then we have its reciprocal trig function. So it's just a reflection But that's what that graph looks like. So now I'm going to fill in the values for secant of theta and then graph it. So there are the values. I'm going to go ahead and graph it. It's going to be the same scale as we did for cosecant. I'm going to start with the asymptotes. So the asymptotes here are at pi over 2, 3 pi over 2, negative pi over 2, 3 pi over 2, and then the graph is going to look very similar to the other one. It's just going to be shifted a little bit. And the same relationship with cosine and secant would hold. All right, now I'm going to fill in the values for tangent. So tangent's going to be the y value over the x, or the sine over the cosine. So at 0, we have 0 over 1, which is 0. 0.7 over 0.7 is 1. 1 over 0 is undefined. And we have a negative 1, 0, positive 1, undefined, negative 1, and 0. Going back here, that's a negative 1, undefined. This will be 1, 0, negative 1, undefined, 1, and 0. So now let's graph tangent. Again, this is going to be 2 pi, negative pi. I'm going to make this 1 and this negative 1. So I'm going to start with my asymptotes. The asymptotes for tangent are at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. Okay, so 0 is at 0. 1 is at, or pi over 4 is at 1, and negative pi over 4 is at negative 1. So you have these three here, but it's not a line. It's going to look like this, where it's going to approach the asymptotes. And it's going to repeat that over and over again. So that is the graph of tangent. And we'll do the same thing with cotangent. Okay, here are the values for cotangent. We're looking at the x over the y. And we will graph this one. The asymptotes for cotangent: negative pi over 2, negative pi, 0, pi, and 2 pi. And then this one, if we look at the pattern, goes 1, 0, negative 1. So these are all going to go down rather than going up like tangent. So it's going to be 1, 0, negative 1, 1, 0, negative 1, 1, 0, negative 1, and 1, 0, negative 1. So here are the graphs of all 6 trig functions. So our focus now is going to be on specifically sine and cosine. The amplitude is going to be the distance from the midline to the maximum or the minimum. So referring back to my graph, the amplitude is that distance there or that distance there. So for sine and cosine, that amplitude is going to be 1. Period is how long it takes for the graph to complete one cycle. So let's look at sine. So sine keeps repeating itself. Here we have 2 full cycles of this function. So it takes from 0 to pi before it starts repeating. So the period of sine and cosine is 2 pi. I'm going to use my calculator to come up with some conclusions. So on the calculator, we're going to graph sine of x and 2 sine of x. For my window, I'm going to go from 0 to 2 pi in the x direction, and my y is going from -5 to 5. So we're going to graph. We have sine of x there, and this is the graph of 2 sine of x. Okay, the amplitude of sine of x is 1. The period is 2 pi. The amplitude of 2, if we look on the graph, is 2, but the period is still 2 pi. So let's go ahead and look at cosine and 4 cosine. Graph them on the same window. There's cosine, it starts at 1, and there's 4 cosine. So the amplitude of cosine is 1, its period is 2 pi. The amplitude of 4 cosine, if we look at the graph, is 4. Period is still 2 pi. So the conclusion is y equals a sine x and y equals a cosine x has an amplitude of the absolute value of a, because if it's a negative, we'll look at what happens later, but whatever the number out front is, that's going to be our amplitude. So the amplitude of 3 cosine of x is 3. The amplitude of 1/4 cosine x is 1/4. The amplitude of -2 sine x is 2. Now let's go ahead and graph sine of x, sine 2x, and sine of x over 2. Sine x. I'm just going to do these one at a time. So sine 2x. Okay, so sine of x. I'm going to go ahead and change my window just a little bit to -2 to 2 so we can see this a little bit better. But our sine graph still has an amplitude of 1 and a period of 2 pi. Sine 2x still has an amplitude of 1, but the period, if we look here, we actually went through 2 cycles. The time it takes to complete one cycle is pi. Okay, and in the span of 2 pi, it repeated 2 cycles. Let's go ahead and look at sine of x over 2, or that would just be 0.5x, and graph that one with the sine function. All right, so this one is only completing half of a cycle in this time. So it's going to take 4 pi to complete one full cycle. Amplitude is still 1, but our period is 4 pi. So let's look at the relationship between that number in front of the x and what our period is. So sine x has a period of 2 pi. Sine 2x has a period of pi, so it's half of it. Here it's double. So the way we calculate these, it's going to have a period of 2 pi divided by whatever that number in front is. So 2 pi divided by b. All right, So let's look at these functions, and we're going to fill in the amplitude, the period, and the number of cycles that'll happen between 2 pi. So the amplitude here is 1. The period is going to be 2 pi divided by 1/2, which is going to be 4 pi. The number of cycles is going to be 1/2. In fact, this number is just going to be the number in front of x. Amplitude here is 3. Period is pi over 2. The number of cycles is 2. This one has an amplitude of 4, a period of 2 pi. Sorry, this one should have been 2 pi over 2, which is pi. 2 pi over 3, so we can leave that. This is going to go through 3 cycles. Amplitude here is 1/2. The period is going to be 2 pi divided by pi, which is 2. And it's going to go through pi cycles through 2 pi. Okay, we're going to do one more on the calculator here. We're going to compare sine and negative sine, and you should probably already know what this is going to do, but let's go ahead and confirm. So there's our sine curve, and there's negative sine. Okay, so what it does is it takes the graph and it reflects it over the x-axis. So now we're going to do some graphs. So we're going to graph one cycle of 3 sine of x. The amplitude is going to be 3, and the period is going to be 2 pi divided by 1, or 2 pi. So on my y-axis, we're going to have a maximum value of 3 and a minimum value of -3. Now along here, what I'm going to do is I'm going to take the period, I'm going to put that out here, so 2 pi. So we're going to complete one full cycle in this time. We're going to divide this, and this is always going to be the case, into 4 equal pieces. So I'm going to cut it in half, which is pi. Then I'm going to take that and cut that in half, which is going to be pi over 2. And then I'm going to put one right in the middle here. So you can either add these and divide by 2, which would be 3 pi divided by 2, or just count pi over 2, 2 pi over 2, 3 pi over 2. Okay, then we're going to graph sine. Sine is going to start at the midline, going to go up to the maximum, back to the midline, to the minimum, back to the midline. The graph of sine is infinite. It would keep repeating this, but for our purposes right now, we're just going to graph one full cycle. Right, our next one, cosine of 2 pi over 3. The amplitude there is going to be 1. The period is going to be 2 pi divided by 2/3, which is going to be the same thing as 2 pi times 3 over 2, which is going to be 3 pi. So this is going to complete one cycle in 3 pi. So I'm going to go ahead and label this 1, this -1 for the amplitude. On this axis, I'm going to go out here and put 3 pi. Then I'm going to cut that in half. That's going to be 3 pi over 2. Then I'm going to cut that in half. So my increments are 3 pi over 4. So this is 3 pi over 4, 6 pi over 4, 9 pi over 4. Then we're going to graph cosine. Cosine, when it crosses the y-axis, crosses at the maximum. Then it's going to go to the midline, to the minimum, to the midline, to the maximum. Now we don't want to connect this with like straight lines. We know what this looks like. So that would be one cycle of cosine. Okay, this one our amplitude is going to be 2. Our period is going to be 2 pi divided by pi, which gives us 2. So my max is 2, my minimum is -2. On this axis, we'll put 2, cut that in half, cut that in half. So this is 1/2, 2 halves, 3 halves. This is going to be a sine curve, so it's going to look like the one on the top. Starts at the middle, goes up, middle, down, middle. Okay, this one has an amplitude of 4 and a period of 2 pi divided by 1/2, which is the same as 2 pi times 2, or 4 pi. So this is going to be 4. This will be negative 4. And then I'm going to take 4 pi. This will be 2 pi. This will be pi. So pi, 2 pi, 3 pi. This is a cosine, so it's going to start at the maximum, midline, like so. Okay, and when you do these graphs, I'm going to require that these 5 points are always present. You don't want to just do like a squiggly. The 5 points are very, very specific. So let's do one more graph here. So we have an amplitude of positive 2. The amplitude is always a distance, so it's always positive. The period here is going to be 2 pi divided by pi over 4, which is 2 pi times 4 over pi, which is going to be 8. So we have 2, negative 2. I'm going to go out here. This is 8. Cut that in half is 4. Cut that in half is 2. So 2, 4, 6, 8. This is a negative sign. So it's still going to start at 0, but it's going to go down this time first. All right, and this last example on this page, we have this graph here, and we're identifying the amplitude and period from the graph. So the amplitude is 4. The period is how long it takes to complete one cycle, which is going to be 8. All right, our last two examples are writing the equation. So we're going to write an equation of sine with an amplitude of 3 and a period of pi over 4. So in our general equation, y equals a sine bx, we need to find the a and the b. A is just going to be 3. For b, if b is equal to 2 pi over the period, I can multiply the period over and divide, so the period, sorry, and I did this backwards. We know the period is 2 pi over b, which means b is going to be 2 pi over the period. So here, my b is going to be 2 pi divided by pi over 4, which is going to be 8 again. So this is going to be sine 8x. A period, or an amplitude of 5, a period of 8, and is reflected over the x-axis, which just means there's going to be a negative. So this is going to be 5 cosine, negative 5 cosine, 2 pi over 8, which will be pi over 4. So this will be pi over 4 times x. So that's how we graph sine and cosine. Next time we're going to add translations, moving it left, right, up, and down.